Hello everyone. This video is going to look at how to come up with an equation if you're given the graph of a quadratic or a cubic function. Okay? Before we start, you're welcome to just push pause and read this, but I'll just say it quickly. You must know something about x-intercepts or zeros regarding one of these types of functions. So for a quadratic, for example, there's a situation where you might have no zeros, kind of like this one here. I'm doing the yellow pen, I don't know why, but just because it was hard to see that. So there's no zeros there, there's no x-intercepts. It may have 1 0 or 2 zeros. Here it is if it's 1 0, it's just coming down and it's touching this one spot and going back up again. But if it were a parabola, by the way, if it were a parabola, it would have to touch that spot. Some people describe it as touching that spot twice, but it's actually just coming down and tapping, let's see, 1, 2, 3, 4, twice. I guess we'll practice that on the next page, but we'll get to that. And then there's the traditional parabola that cuts through nicely in two different spots, right there and right there. Okay, but these are three situations that a quadratic equation or a parabola can look like when it's a graph. It may or may not have 2 zeros. It may have none, it may have 1. And in the equation you would write it twice, the same 1 twice. Or it may have 2 different zeros like this one. Okay, I've said enough there. Here's a cubic. This is the basic shape of a cubic right here. It may have, there's never a situation where there's no zeros in this case, if it's a positive cubic function, but let's look and see. It might have 1 0. It may have 2, 1, 2, or it may have 3, 1, 2, 3 zeros. Wow, as if that isn't confusing with all those little yellow dots. It's just something that you need to know as we carry on here, okay? Let's look at the first question. So you're given a graph like this, and you're supposed to come up with an equation. You don't have to come up with an equation in standard form. It can just be in factored form, which means it could just have some brackets, okay? Your teacher may want you to multiply it all out once you've got the stuff in brackets, but in the meantime, oh, I just heard a call on line 1, but I don't think it's for me. Okay, I think we're okay. So let's look over at this cubic function. We can tell it's a cubic because of the shape here, and we know it's positive, and I hope you've watched the past videos that I've made on all of these polynomial graphs. Okay, there's at least 2 or 3 videos that I've made that will that are good background to what we're talking about here. Okay, anyway, so here's 1 0 or x-intercept or root. Here's the other one, and here's the other one. Okay, there's a -3, a 2, and a 4. If we were to write that with brackets, the -3, remember it's the opposite of what you see. So instead of -3, it's going to be +3 right there. That's the first 0. And again, if you haven't watched those other videos, this is going to seem really weird because I'm jumping right now into this stuff. So we have a 2 here, so it's going to be x minus 2 here. And the last one is a 4. Remember, it's going to be x minus 4, not x plus 4. Okay, here we have an equation. If you were to go to Desmos, which is my favorite online graphing calculator, you'd think I was an employee of them the way I advertise for them. If you were to go to that website or that app that's free and graph this, you would have a beautiful looking graph. In fact, it would look a lot like this because I used Desmos to create the pictures that you see on this video. Pretty cool, eh? I did not draw this freehand. I know you thought I was that good, but no, I did not. Here's the equation we were looking for. Some teachers may say you have to multiply this all out. In my case, or in my class, we wouldn't have to do that in this case. I would stop here and say, good enough. If you were to type this in Desmos, you would get this graph. That's all I was looking for. Okay, next question. Here's another graph. Again, it is a cubic. You can tell by the shape, okay? It's not a parabola. It's got that cubic shape to it. So let's quickly do this since I don't want to waste too much of your time. You have other things you want to do too. I know there's other subjects that are important out there. Although math is my favorite because all math is doing puzzles. It's like doing puzzles all day. Okay, so we have a negative 3 here. Remember, it's going to be a plus 3 on this. Here we have a positive 2. It's going to be a minus 2 when you write it this way. Here we have a 4. That will be a negative 4 on here. Now, the only thing you have to remember, and of course, there was a little curveball thrown in this question. It's not going to be identical. Notice how this one starts at the bottom, makes its way up. And if you know the basic shapes of polynomials, which is a video that I've done before this one, you will know that this one has been flipped upside down. And so we're going to need a negative sign here because it is not behaving the way a positive cubic function would. It's actually doing the opposite of what a positive cubic function is. It's negative. It's been flipped. Okay, it's been flipped upside down. Okay, this would be our equation for this one, folks. I would be happy with this, and I would move on. And let's do that. Here we go. This one is another cubic function. It's got that shape. However, it's got a situation where it looks like it's only touching right there and right here. Now, if you remember back to the first page, sometimes you have situations like this with cubic functions where it's only appearing to touch twice. So this is how you deal with it. It is starting in the lower left and ending in the upper right. So it's going to be positive. But in this case, we're going to write this, and that's a positive 2. So you'd write it like this. We're going to write this twice because it's touching this spot and then moving down and then coming through at x at the positive 4. So I'm going to put x minus 4 right here. But we have to write this twice because this is a cubic. If I wrote it only once, it would be a parabola, and this is definitely not a parabola, okay? It is positive. I'm not going to put a negative sign here because it's starting in the places that a positive cubic function does, which is lower left, ending up on the upper right. Notice it's not in quadrant number 1, 2, 3 over here, but that's okay. It's still got that same shape that a positive cubic function does. Okay, so this is the answer we were looking for, or I was looking for in this case. You could write it like this if you wanted to. That's the same thing. Okay, this is just written twice, but I just wrote it this way to keep it a little more consistent with the other questions we were doing. Okay, next question if there is one. Yay, there is. Why would we want to stop? This is too much fun. Okay, this is obviously a question or a picture that has an even numbered degree. In fact, let's see, what's the title of this? The title of this video is actually off a little bit because this is a quartic function. It's called a quartic because it's probably to the 4th degree. So a quartic function usually looks like a W, okay? If it's positive. If it was not positive, it would be a flipped W, looking more like an upside down W. And there's enough McDonald's signs in the world, so there's no need for me to say that name. They have enough advertising as it is. So it's a positive quartic. Let's just go about our business. X, so there's a 1 there, a negative 1. So let's write this, x plus 1. We're doing the opposite of what we see there. Here is a 2, and here is a 4. Ooh, there's only 3 spots. You can tell that this spot here we're going to write twice because it's a quartic. We need there to be 4 things in brackets, and this is the culprit right here. So that's going to be opposite of 2 is minus 2, x minus 2, x minus 2. And on the end we have a 4, so x minus 4. If you were to type this in Desmos, hopefully you would come up with something that looks just like this beautiful piece of art. And this would be the equation we were looking for, folks. Okay, if it was upside down, we would just put a negative sign there. Okay, here's another question. This time, it is back to the title of this. It is a quadratic. It's a parabola. Okay, it's got a 0 and a 4 there. How do you do that? By the way, it's a positive parabola because it's starting in the top left and ending in the top right. So we've got x. Should it be plus or minus 0? Actually, it doesn't matter. You could just put it like that. And over here we have a 4, so x minus 4. This is very unusual to see it written like this, so probably a better answer would be, well, x plus 0 is just x. So writing it like this is really the same thing as this. Okay? That's really the same thing. So this is probably the best answer. Your teacher would really like to see this answer, I'm sure, because it just looks more neat and tidy. Okay? We're all neat freaks, eh? Us math teachers? I don't know. Yeah, that's probably not true. Anyway, that is the end of this video. I hope you've learned a thing or two about how to graph, or not graph, how to look at a graph and come up with an equation that would create that graph. Okay? Again, use Desmos to check your answers just to see if it makes any sense, what the heck I've been talking about. Have a great day. Bye.